Okay. So there's only 2 more sections in this chapter before we take our test. So first half of your test is over chapter 7, which is all the law of sine, law of cosine, area stuff we did right before break. Second half of the test is going to be over these 2 sections that'll kind of like sum up chapter 6 that we were doing before, which is solving trig equations. Yes, sir.
Is there a quiz for like this part of chapter 6?
There is not a quiz. No, because it's just 2 sections. So we're just going to do 2 sections. Did I give you guys? I think I gave you the new calendar before break, right? So we're going to do 6-5 today and tomorrow. We're going to do 6-6 Wednesday, Thursday. Friday this week is a Math Excel work day. Then, the other one out. Next week is review test, and then a couple more days of review and test the following Monday. We've got kind of a weird week next week because you have a delayed start Thursday and Friday. So we only have like half periods those days, and then we don't have school on Friday next week at all for Good Friday. So it's kind of a short little weird week, but the next like 5 days after these 2 sections will just be reviewing and testing. Like all that stuff online. If you want to check out what it looks like earlier. Okay, so 6-5 and 6-6. We're going to be solving trigonometric equations. Most of the stuff we're going to do is going to come from your unit circle, which is why it's helpful to just kind of have one out ready to go. Again, you won't have a filled out unit circle on your test or quiz, but you at least need to know how to use it. So we're going to start with some basic ones here, and then we'll kind of get a little progressively more involved with them. Okay? So let's say I gave you this equation. Sine of x minus 1 equals 0. And I said solve for x. Okay. So x is an angle. Okay. It could be a degree or a radian. Because it could be a degree or a radian, the instructions on these problems are always going to be really specific. This one, that thing wasn't covering it, says we want answers in radians. Okay. And it's going to bounce back and forth. So just make sure you read really carefully. Okay, sine x minus 1 equals 0. The easiest way to solve if you have a single trig equation is just get it by itself. So if I move that 1 over, I have sine x equals 1. And 1 is a value of sine that is on our unit circle. So if you look at your unit circle, which angle or angles in radians have a sine, a y value of 1? Here we have a sine of 1 on our unit circle. Pi over 2 in radians. Yep. Okay. You could do inverse sine to get rid of the sign, but the calculator is going to give you a weird decimal instead of this pi over 2, and we always want exact answers. So we're going to refer to our unit circle whenever possible. Okay, there's no other places on the unit circle where sine equals 1, but every time I rotate around the unit circle, there's going to be another place where sine equals 1, right? Every rotation, every period of the graph. So what we do to include all of those other possible rotations are we do this guy that we did before with like our asymptotes and zeros. If you guys remember when we did like our tangent, cotangent graphs, things like that. We're going to say plus 2 pi k. 2 pi is the period of sine, okay? And k, do you remember what k is? An integer. Yep. And that accounts for then all of the solutions that we could possibly have, all of the places where sine would equal 1. So pi over 2 plus or minus any multiples of our period. Okay, let's look at cosine of x equals rad 2 over 2. In this one, cosine's already alone, so that's nice. So you can just go ahead and find that on your unit circle. Where does cosine equal rad 2 over 2? And there are 2 of them. So we want to list both. One's in quadrant 1, the other is in quadrant 4. Yes? Pi over 4 and 7 pi over 4 are the 2 places on our unit circle where cosine, my x-coordinate, is rad 2 over 2. And then every time I rotate around, I'll get another place where cosine equals rad 2 over 2. So to each of those, we're going to say plus 2 pi k. That's it. Those are our answers. Okay, 2 cotangent x minus 2. Okay, so the first thing I'm going to do is get my cotangent alone. So I'm going to add 2 and divide by 2. So I get 1.
There are two places on your unit circle where cotangent equals 1. These ones are a little bit harder because they're not just directly points. You're going to have to kind of think about how you divide an x divided by a y to get cotangent. Cotangent is positive in quadrant 1 and quadrant 3. So that's where we're looking, quadrant 1 and quadrant 3. Where in quadrant 1 do we have a cotangent of 1? Pi over 4. And where in quadrant 3? 5 pi over 4. And then if I want to include all solutions, we're going to add the period times k. What's the period of tangent and cotangent? Those were the two that were weird. Do you remember? Pi. Okay, everything's 2 pi except tangent and cotangent are just pi. Now, here's the thing about tangent and cotangent. If I take pi over 4 and I add 1 pi to it, so I let k equal 1, I actually get 5 pi over 4. That 5 pi over 4 is included in the pi over 4 plus pi k, because we add 1 pi onto pi over 4, we get 5 pi over 4. So this second answer is actually redundant. Because we have 2 periods within one rotation of our unit circle, we don't have to list both of them here. If you do, it's not wrong. You're just saying the same group of things 2 times. Okay? Any questions on those 3? Okay, moving on. All right, so let's talk about ones. These are the ones we're going to need our calculator for if they're not on our unit circle. All right, so find all solutions for cosine of x equals 0.7. We're going to round solutions to the nearest tenth of a degree. Okay, so if it says round, if it's a value that we know, like cosine goes between -1 and 1, 0.7 is a value of cosine. It's just not on our circle. This is where we use inverse functions. Now, on your calculator, double check that you are in degree mode real quick first, which you probably are from all those triangle problems. Okay, and then we're just going to do the inverse cosine on both sides here. Okay, so I'm going to get x equals, and it says nearest tenth of a degree, whatever the inverse cosine of 0.7 is. So inverse cosine of 0.7, I get 45.6 degrees. Okay, and if I want all solutions, we're going to add the period times k. We just have to remember what the period is if it's degrees. So normally it's 2 pi if we're in radians. What's the period in degrees? 360. Okay, now here's the bad thing about the calculator. The calculator only gives you one of 2 possible solutions. If you think about a full period of cosine, there's actually 2 places where it's going to equal 0.7. One of them in quadrant 1, which is what we got, 45.6. That's a little arrow there. Okay. What other quadrant is cosine positive in? Quadrant 4. Okay. This is the one the calculator doesn't give us because inverse cosine is only defined in 2 quadrants. It's not defined in all 4 quadrants. We've got to find this one ourselves. And here's how we do it. We use reference triangles. We have 45.6 already in quadrant 1. Okay, you can draw those nice little right triangles that we're used to. We know the other angle I'm looking for is in quadrant 4. And it will have the same reference angle because it has the same cosine. So that is also 45.6, okay? But it's 45.6 in the negative direction. You need to find the standard angle. So from the positive x-axis, rotated counterclockwise to get to that hypotenuse. So in this picture, and it's going to be different for each quadrant, it's a full rotation except for 45.6. So we just do 360 minus 45.6, and that's going to be our second answer, which is 314.4, and then again, I'd say plus 360 times k. If you want to check it, plug it in. Take the cosine of 314.4 in your calculator, and you're going to see it's about 0.7. Okay, so you can double check that you did that right. Just plug it in. Actually, all these problems, it's solutions to an equation. You can plug them back in, make sure they work. Just make sure you're in the right mode. Okay, let's try another one of those. Find all solutions to tangent of x equals -2. Okay, so first thing I'm going to do is inverse tangent. On each side, we are still in degree mode. Inverse tangent of -2 is -63.4 degrees plus the period times k. What's the period in tangent if we're in degrees? 180. Okay. Tangent and cotangent, you could find the other one with a reference triangle, but it's just going to be whatever -63.4 is plus 180. It's already included in this. You don't have to list the second one because this gives us all of our solutions in one bunch. Okay. If you do list the second one, if you do find a reference triangle, it's actually just the same group of numbers over again. Okay. So tangent, cotangent, a little bit easier. All right, let's try one more of those. So 2 cosecant of x minus 3. Actually, this is, well, this is a decimal one, I guess. Equals 0. This one, we want solutions on the interval 0 to 2 pi, rounding to 4 decimal places. All right, so we'll mess with the instructions in a little bit here. Let's just go ahead and get that cosecant alone first. Okay, so I'm going to add 3. And I'm going to divide by 2. So 3/2. Okay. We don't have an inverse cosecant, an inverse secant, and an inverse cotangent. So if you have one of these and you need the calculator for it, just take the reciprocal. We know the reciprocal of cosecant is sine. So this is just a sine problem. Okay, so we need to find where does sine equal 2/3. Inverse sine on both sides. And in this problem, now we want to worry about those instructions. Okay, the instructions say we want answers between 0 and 2 pi. So am I in radians or degrees? It's in radians. Okay, so double check that you are in radian mode. I want to change it, hit mode, go to radians. Okay, and then inverse sine of 2/3. I get x equals 0.7297. It said 4 decimal places. That's a radian measure. What 2 quadrants is sine positive in? Quadrant 1. That's my first answer the calculator gives me. And then quadrant 2 is the one that we're missing. Okay, so let's do our little triangles. Quadrant 1 has a reference angle of 0.7297. It's kind of gross, but that's it. Quadrant 2 has that same reference angle, 0.7297. We need to find, again, the standard angle. So from the positive x-axis, rotated counterclockwise. What radian measure are you at if you're on the left side of the x-axis? Pi. So what calculation am I going to do to figure out that rotation there? Pi minus that decimal. And that's it. Or you can do 3.14, whatever. But it's 4 decimal places, so I think I'm going to use my pi. 0.7297. 2.4119 if I give it 4 decimal places. And then again, you can check it. You can plug it back in, at least to the sine equation. You can take sine of both of those numbers in radian mode and double check that you get about 2/3 out. Now, this problem didn't say find all solutions. It said we only want answers between 0 and 2 pi. So we do not have to put plus 2 pi k at the end of these. Only if it says all solutions are we going to include that. That includes every rotation. If it just gives us one interval, we just stop at this point. Those are our 2 answers. Notice the 0 to 2 pi, by the way. Remember, bracket means equal to, parentheses means not equal to. So that tells you we're just using our first rotation, but if my answer's at 0 and 2 pi, which are at the same place on my unit circle, we use 0, we don't use 2 pi. That's what those parentheses in the brackets tell me. Okay. All right. Honestly, these calculator ones with the reference triangles, I think these are the hardest ones of the whole section. Okay, so we're past those now. All right. The rest of them are going to be exact values on our unit circle. So let's look at this one. 2 sine of x minus pi over 4 plus 1 equals 2. Okay, so all these we're going to get exact values. Here we want answers on the interval 0 to 2 pi, so we're in radians. We only want that first rotation on my unit circle, that one period of the graph. Okay, so the x minus pi over 4 is kind of gross here. So what I do in these problems is a little substitution, okay? I'm going to make that parentheses, that weird angle that I see, just a theta, okay? And I'm going to solve the simpler equation first. So 2 sine theta plus 1 equals 2. Okay, and this is one that we've just been practicing solving so far, okay? So I'm going to get sine alone. I'm going to subtract 1, and then I'm going to divide by 2. So a half. Okay, and then that's something that's on my unit circle, and there should be 2 of them. Where on your unit circle does sine equal a half in radians? Pi over 6, quadrant 1, 5 pi over 6 in quadrant 2. Good so far? Okay, so that part's really just like review. Now, at the end, we're going to go back. Theta is the same thing as x minus pi over 4. So instead of theta, I'm going to put x minus pi over 4 back in. Because ultimately, that's what I'm trying to solve for. I'm not solving for theta. I'm solving for x. Okay? So x minus pi over 4 is what's equal to pi over 6. Or x minus pi over 4 is what's equal to 5 pi over 6. In both of those equations, how do I get the x alone? Common denominator, and then what do you have to do? Add pi over 4. Okay, so whatever pi over 6 plus pi over 4 is, and whatever 5 pi over 6 plus pi over 4 is. And those are my 2 answers. Pi over 6 plus pi over 4, what's the common denominator? 12, so you can think of it as 2/12 and 3/12. We're going to get 5/12 for that answer. Okay, and then for the other one, also 12s. So 10/12 and 3/12 gives me 13/12. Exact answers. You can plug them back in radian mode and make sure they work. Okay, any questions on that? No, nada? Okay, let's keep going. Let's do some different ones. Actually, you guys try these ones, I guess. Go ahead, see what you can do. I think both of these we can get exact answers for. Let's do answers. Let's just stick with the between 0 and 2 pi for our interval. Okay? Go for it. Okay, let's check them. All right, so for the first one, I got the secant alone, and then I flipped it to make it a cosine. I think that makes it a little easier to recognize. And then you can just find the 2 places where cosine equals negative rad 3 over 2, which are 5 pi over 6 and 7 pi over 6. For the other one, you have kind of a weird angle there, so I made it a theta to start, solve the easier equation. The 2 places where cosine equals negative rad 2 over 2 are 3 pi over 4 and 5 pi over 4. That's what theta equals. Then put back in the x plus pi over 3. So to solve that, I have to subtract pi over 3 from both of the angles I found. So 3 pi over 4 minus pi over 3 would be, again, 12ths is the common denominator. 9/12 minus 4/12, which is 5/12. And then for the second one, you're doing 15/12 minus 4/12, which gives you 11/12 there. Okay, and then all of these, again, like if you're doing it in Math Excel and you want to check it before you type your answer in, if you don't want to waste an attempt, you can plug the answer in the equation, just make sure in the right mode, make sure it works. Okay? What questions do you have on these 2? We're just going to do 2 more problems real quick, and then that'll be it for today. Okay, so last 2 problems then. You're going to see a couple that have some squareds in them, and this just involves taking square roots. We are allowed to take square roots now because these are equations. These are not identities that we're solving. That was only something we weren't allowed to do if we didn't know they were equal or not. Here we know they're equal, so we're going to be using square roots to get rid of those squares. Okay, again, we're still finding all solutions on the interval 0 to 2 pi. Okay, so we don't have to worry about adding on that period times k at the end of it. All right, so 4 sine squared equals 1. First thing I'm going to do is divide by 4 on both sides. That'll give me sine squared, maybe. Try that again. There we go. Sine squared equals a fourth. Okay, and then I'm going to take the square root on both sides. If you have a fraction, remember you're just square rooting the numerator and square rooting the denominator. So the square root of 1 gives me 1. The square root of 4 gives me 2. And then if we take a square root, we want to include a plus or minus in front of it. And that plus or minus means you're going to have more solutions here. We're looking for anywhere on our unit circle where sign is either positive a half or negative a half. So there's going to actually be 1 in every single quadrant. And you're going to notice when you do these, they all have the same reference angle. So it's going to be, with our radians anyway, all the over 3s or all the over 4s or all the over 6s, whatever it happens to be that we're looking for. So the first place that sine equals a half is at what radian measure in quadrant 1? Pi over 6. And then you'll notice as you go around the circle, everything that's over 6 will have that same sign, either positive half or negative a half. So 5 pi over 6. No, wait, not over 6. Is it over 6? Yeah, okay, sorry. Thinking of my cosine for a second there. 7 pi over 6 and 11 pi over 6. Okay, so those are pretty quick and easy. Last one, 3 cosecant squared equals 4. First thing I'm going to do is get rid of that 3. Okay, so I'm going to make it cosecant squared equals 4/3. Then I'm going to take the square root of the top and the bottom. So don't forget your plus or minus. Square root of 4 is 2. Square root of 3 we're just going to leave as rad 3. And then I can't find cosecant super easy on my unit circle, but what can I find on my unit circle instead? Sine. So instead of this, we can look for where sine equals plus or minus the reciprocal, rad 3 over 2. And then these are going to be all of our pi over 3s. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So you can see that plus or minus is important. It's giving us 2 extra solutions. So if you forget the plus or minus, it's a quick -2 instead of a -1 on your test. Yep.
What would we do if we didn't have an interval? Like if we had that?
You would say this, and then next to each of them, you'd say plus 2 pi k. You just have that extra little bit.
So when is it just pi k?
Only if it's tangent or cotangent,
Oh,
because that's the period. It's always the period times k. It's telling us how often that answer is going to repeat. Okay, so everything's 2 pi or 360 except tangent, cotangent, or pi or 180 if you're in degrees or radians. Okay, so tomorrow then we'll do the second half of this lesson. You guys can start on your Math Excel if you want. You've got almost 20 minutes now. 6-5 Math Excel is due on Friday this week. That's your first lesson. So one is due on Friday. The other one's due on Monday night. So we're a little close together, but you've got some time to work. Yep.
is that my one that did 9/8, like on this 9/8 or?
We don't have 9 weeks. Neither. On the semester. Okay. Yep. Everybody said 15 minutes at the end of the period last Friday. So here you go. All right, I'll do cell phone model.